You know, before a single shovel ever hits the dirt on a construction site, the entire project has pretty much already been built, digitally. Today, we're going to pull back the curtain on the software that is the invisible blueprint for our entire modern world. It's a huge question when you stop and think about it, right? I mean, picture a massive skyscraper with thousands upon thousands of parts and dozens of different teams. How on earth do you get all of that organized and perfectly aligned before you even start building? Well, the answer is a whole suite of specialized digital tools. And these aren't just some fancy drawing programs. No. We're talking about incredibly powerful systems designed to manage every single piece of information a project needs, from the very first line drawn to the final bolt being tightened. So we're going to take a little journey from blueprint to build. We'll start with how drawings are made with insane precision. Then we'll see how project-wide standards get set, how teams can actually collaborate on one single plan, and finally, how that digital blueprint gets delivered to the construction site. Okay, first stop, drawing with digital precision. This is really where the geometric soul of a project is born, one perfect line at a time. And to really appreciate the digital way, you just have to think about what it replaced. I mean, manual drafting, it was painfully slow. One little mistake could totally ruin a giant sheet of paper, and making any kind of change was an absolute nightmare. Digital tools, on the other hand, made the whole process fast, incredibly accurate, and wonderfully flexible. At its very heart, it all begins with the basics. Everything in a super complex building plan is actually constructed from these fundamental geometric shapes. The software just lets designers create these building blocks with perfect mathematical precision. But how is that precision even guaranteed? It's definitely not about having a steady hand. The secret is that the software has these built-in tools, like grid and object snapping, that basically act like magnets, pulling lines to the exact right points. And all the while, coordinate systems are giving every single object a precise address in digital space. And this is where the real magic of digital just shines. Need to move a wall? You just select it and move it. Need to duplicate a window 100 times? That's literally a single command. Changes that would have taken hours, maybe even days of manual redrawing now happen in seconds. All right, so once you can draw with precision, you need some rules. So welcome to Section 2, Building with Standards. This is all about making sure everyone on the project is drawing the exact same way. And here's why that matters so much. Without standards, a project with a bunch of different designers just becomes a chaotic mess. These standards are the shared rulebook, making sure every part of the plan speaks the same visual language, and that is absolutely crucial for quality on the job site. So what do these standards actually look like? Well, they usually fall into two main types. First, you have graphic standards, which control the visual look, things like line thickness or the specific color for electrical wiring. And then you have information standards, which control the layout, like the official title block that has to be on every page, or the standard symbols for doors and windows. Another massive time saver that comes from having standards is reusability. I mean, why draw a desk or a sink or a structural connection over and over and over again? You don't. Instead, teams create these libraries of standard objects that can just be dropped into any drawing, which saves an incredible amount of time. Okay, now for part 3, structuring for teamwork. A building isn't designed by just one person. It's a total team sport with architects, engineers, specialists. So how do they all work on the very same plan? Well, this problem is solved by one of the most powerful concepts in digital design: layers. The best way to think of them is like a stack of clear, transparent sheets. You can draw the structural columns on one sheet, the plumbing on another, and all the electrical on a third. So here's how that works in the real world. First, every object gets assigned to a specific layer. Then, and this is the genius part, you can turn the visibility of these layers on and off. The electrician can turn off everything but the electrical layer to work without any distractions. Each layer can also have its own settings, like a specific line color or weight. So, when it comes right down to it, layers are what prevent total chaos. They let dozens of specialists contribute their expertise to a single unified model without stepping on each other's toes. This is really the heart and soul of digital collaboration. And this whole organized structure is the foundation for even more advanced technologies. It's what makes 3D modeling possible, and it's the basis for something called Building Information Modeling, or BIM, where every single object in the model is also packed with tons of data, like its material or its cost. We've reached our final section, delivering the final blueprint. All this amazing digital work has to be packaged up and sent to the people who are actually going to build the thing. And the final package isn't just one drawing, it's a complete information set. You have the detailed drawings, sure, but you also have things like schedules, which are basically spreadsheets listing every single door and window, and specifications, which are the written documents detailing all the materials and quality standards. Now, to make the drawings actually buildable, you have to add a whole layer of explanatory information. Digital tools let you precisely place every dimension, every note, and every marker that tells the construction crew exactly what to do and where to do it. Of course, all this digital information eventually has to be formatted for the real world. The construction industry runs on standard paper sizes, like the A series you see internationally or the imperial sizes in the US. The software handles all the complex scaling to make sure everything fits perfectly on these sheets. Getting from the computer screen to the construction site involves a few final key steps. Designers create specific views from the main model, they set the correct scale, and arrange them on the official sheet template. They even control which layers get printed, just to make sure the final document is clean and easy to read before it's plotted out. So, what does this all really show us? It's a fundamental shift. These digital tools have transformed construction from a pretty manual craft into a modern industry, one that is incredibly precise, deeply collaborative, and massively more efficient. I mean, these are the tools that have built the world we live in today. And that leaves you with a pretty exciting question to think about. If this is what today's digital blueprint can do, what kind of world will the tools of tomorrow build?